Yeah, the payoff for our multi-body part is being able to extract these, right click, and we are looking for save bodies. If I was on one of the individual, I could insert into a new part, which is slightly different. Save bodies gives me the opportunity though to go ahead and auto assign names where it picked up the solid body names. We do not want to consume and propagate visual properties. If we use those, we'll go ahead and put that in. The origin location should default. And default templates, and it just went to the standard part. So maybe we would go to my I found part millimeter, and then if we browse to the assembly and go ahead and give it a name. Alright, so it's saving it as type even though it's a SLDASM, it's calling it a split assembly. So there's other functions for this that can come in handy with mold making, or like the lace gasket is one that I use as an example where maybe I have a copper substrate and I'm laying felt or the rubber over top of it, and having a single part with those different materials so that I can utilize it as a single but keep the representation as an assembly. So when I click on Save Bodies, it's going to put it. Dry part has different units. Yes, change the units of the dry parts to the units of the base part. And we should see that 3 times. So at some point I'm going to probably click Don't Show Again. We'll rebuild and save. Alright, so now we have a Save Bodies feature. Anything that I do to the model before, and this may be where you don't want to suppress anymore. If you suppress one of these objects, it's going to rename, and if you have a lot of solid bodies in this strategy, then that can be difficult. So the rollback is a much better strategy, and it doesn't lose its mind. So anything that we put in after the save bodies is not going to participate when we go over to the assembly. So I have my names. These are going to remain fixed. If we float them, they say they should stay. It's not going to be as strange of results as in the top down, but it can give some mixed results. So it generates the assembly, and then within that folder, see if we can get back to it. We'll go into our assignment 9, and there's the base chamber, the cover plate, and the gasket. So it extracted those out, and then things like the exploded view, we can mimic the exploded view in the part, but if we're going to take it to this level where we need to have access to an assembly, we might as well use the explode here. The other thing is, if I didn't need the assembly, I didn't need all of the individual parts for whatever reason, but I did want to show this with the Hex Set, I would probably just draw a 13mm polygon, hex polygon on the top, extruded out 6-8 millimeters. I have to look at the ratio there, but extrude it out and then pattern it around. And then if I knew the weight of this object, let's just say we go in and we want to apply materials, I'm not going to apply materials at this level. I'm going to right click on each of the individual solid bodies, and this one can be plain carbon steel, the cover plate, goes to plain carbon steel. And then the gasket, we added a custom material, and I don't believe I brought it to the top. So if I go back to the custom materials, plastic, select my neoprene, apply it, and close it. Now I can see those differential, the texture or the colors between the parts. We go back into the assembly. If the propagate worked, then I will get the same result, and as we expand these out, I'm going to see that the material, and we get this placeholder that refers back, contains the associativity back to the multi-body part. So at this point, I can go in, if I wanted to use the toolbox, go into the design library, add in metric, bolts and screws. We were using the hex head, and I think we had to do the hex cap. So we'll go ahead and place it. And it gets the M8. The length is the 30 millimeter. And we'll go ahead and accept it. We could pattern it, but for 8 pieces, I probably have just as much luck going through and finding each of those items. And then hitting the X to accept. So another place that we can use the folders is in the fasteners, especially if I'm doing bolts, washers, lock washers, nuts. Then I would go in and add a new folder, and maybe this is hardware. All right, so we can kind of manage our screen space and have a little bit more. So should be, we'll refer you back to assignment 8 for the exploded view. What I want to do is look at make sure that gets saved, is look at the mass properties. All right, so one of the things that would be a concern is if, as I mentioned, if this was a purchased part and we're approximating the value but weight was really an issue, then this would be something, because we've applied the materials, I can go into the mass properties and I can look at its weight, and it's just under, call it 3,600 grams, so 3.6 kilograms. It's pretty heavy. Maybe I measure this and we put it on a scale, and I find that it's actually with the if we drew in the partial hex, that it's actually 4 kilograms, so 4,000 grams. And if I want to override to keep my balance in the assembly, I can go in and put in 4,000 grams, and it will tell me that the user is overridden and 4,000 grams, and then that will affect my center of mass if it is evenly distributed. And if you notice that we could also override the moments of inertia and the center of mass, which I don't really want to do. So we'll look at it from the standpoint of the 4,000 grams. The hex bolts in the assembly, I don't know that when it defaults, they probably just default to water. So when you look at 1 gram per cubic centimeter. So if I want to turn those back off, we can uncheck and apply. So one of the things with the CSWA then is when you're taking the exam, they're going to ask you for these values. If you've gone through and applied the materials, my number should match your number pretty close. Or if we are calculating for the center of mass, yeah, this one isn't as exciting, but the center of mass of 38.5, and if we rotate around, we can see where that location is. So those should also match up pretty close. All right, we're ready for the drawing.